Good morning, all of you. In today's session, we are going to start with the 10th standard chemistry and physics. Unit 9, electrical current, series number 5 is going to be discussed. Earlier, we completed what is the origin of electrical current and how it will be passed in the circuit and what is the use of battery. If we remove battery, what would be the consequence in the illumination of bulb? And that activity performed and the detailed explanation about the electrical current and its another parameters like potential difference, everything got discussed. In addition to this one, unit 1 to 8, entire detailed explanation available in the channel called World of Competitive Chemistry. Now we entered into series number 5. Here we are going to discuss electromotive force exclusively. Let us enter into our today's concept, electromotive force, EMF, how it will be defined, working, and how it is measured. Let us discuss about the concept called electromotive force, simply denoted as EMF. When the ends of the conductors are connected in the terminals of the battery, electrons in the conductor move with the drift speed from the negative terminal to positive terminal because of the electric force acting on them, right? So whenever the conducting material connected with the battery, one is whether positive and either to the negative terminal of that battery, what happens? The drift speed is originated within that, and a negative terminal to positive terminal flow of electrons are possible. Always high potential to low potential, here passage of electrons are possible, so that here potential difference is originated. That is the main cause for this electromotive force, that is clearly depicted in this diagram, where the electrons are traveling with the average drift velocity, and with respect to this drift velocity, the external electrical current movement will be opposite direction. So that is mentioned in this picture. At the time, negative ions equal amount of charge move from the positive terminal to negative, again is the electrical force, because chemical force is operating within the battery. So where the chemical forces are greater than the electrical forces, at that conditions, the electrons are supposed to move from the negative terminal to positive at the against of the electric force, because chemical forces are operating, they are the driving force for these electrons to move in this circuit. Thus, some chemical energy is spent to move the ions in the battery. Some extent of chemical energy is required that used to travel ions from one region to another region in that entire battery. It means that the amount of work is done by the chemical force. Chemical force is driving. This is going to spend some work in order to move the ions. In order to move the ions in this battery, that is given as chemical force. This chemical force is originated from the electrolytic solution within the battery. Let us assume work done by the chemical force to move the negative charge Q from the positive terminal to negative, again is the electrical force Fe, will be W. How extent of this chemical work is operated in order to travel that positive to negative terminal by the charge Q in that electrical force, that is given by W. And assume that magnitude of chemical force is equal to magnitude of electrical force. At that instance, both the forces got equalized. After the movement of ions, after the movement of electrons, the forces get equalized here. The work done on the negative charge Q by the chemical force W is equal to FCD. Here, W denotes work done by the electrical force, and FC is the force originated by the chemical force, and D is the distance traveled. D is the distance traveled in between the two terminals of the battery. Then the work done by the chemical force to move 1 coulomb charge. We are taking the unit charge here, that is 1 coulomb. Q is taken as the 1 coulomb of the charge from the end of positive terminal to another end of the negative terminal. Thus, the equation is given by W by Q is equal to FCD by Q. W denotes work done by the electrical force, and the Q is the unit charge, that is 1 coulomb. FC is the chemical force operated, and the D is the distance between the positive and negative terminal of the battery. Q is the charge, that is 1 coulomb. And at that instance, we know that both the charges, both the forces are exactly equal. Chemical force exactly equalized with the electrical force, right? So that instant, now we will get another equation, W by Q is equal to FED by Q. W by Q is equal to FED by Q is the another finalized equation that exactly is equal to potential difference. This equation exactly is equal to potential difference. This equation we already derived in our earlier session. Now we are going to observe this W by Q is the work done by the chemical force and the unit negative charge to move from the positive to negative terminal. That force, what operating in order to move the electron, the force operating is denoted as the electromotive force that is given by the symbol called epsilon. Epsilon is equal to W by Q. This is the ratio that exactly is equal to potential difference and which alternatively given by FED by Q. FE denotes electrical force and D is the distance traveling by these electrons within the battery in between the two terminals, and the Q is the 1 coulomb of electrical charge. So that is called EMF. By the force with electrons are traveling from one terminal to another terminal throughout the battery, that is given by electromotive force, which is measured in the voltage. If you are taking this galvanic cell, the simplest example where zinc taken here, zinc metal dipped into the zinc sulfate solution, copper dipped into copper sulfate solution, both are denoted as anode and cathode respectively, and both are connected with the voltmeter, which alternatively known as galvanometer, so that it used to measure how extent of potential difference is originated in between these two compartments by connecting with a salt bridge. Generally, EMF is defined as the work done by the chemical forces to move unit positive charge from the negative terminal to the positive terminal of the battery. So, how extent the work has been done by the chemical forces in order to move the unit positive charge from negative to positive terminal in the battery, that amount of work done is denoted as the electromotive force. How can we measure the potential difference or EMF of the cell? These are almost taken as a synonyms to each other. Potential difference, alternatively known as electromotive force, but there is a slight difference. The distance between the AB terminals, this movement of in order to move the positive charge from one terminal to another, how extent of work done by the chemical force is denoted as this EMF, and these two are denoted as a two different terminals, like a positive and negative terminals. In order to migrate the electrons in between these two terminals, the extent of work done by the electrical force is denoted also denoted as EMF. So there is a slight variation, but almost taken as synonyms. This is a slight bifurcation. The EMF meter is used to measure the electromotive force, whereas voltmeter is used to measure the potential difference. As we already discussed, there is a slight variation, slight barrier line is there in between EMF and voltage or potential difference, right? EMF is conveniently measured by the device called the EMF meter, whereas voltmeter can be conveniently applied for measuring this potential difference. In order to measure either EMF or potential difference, we can construct the galvanic cell very simply by taking anode as a zinc compartment and cathode as a copper compartment. Both are connected by the salt bridge, and here electrons are released at the center called anode, and being it is oxidized, converted into zinc to Zn positive, and electrons traveling into the cathodic compartment where seeking of electrons, and copper plus 2 gaining electrons converted into metallic copper, so that potential difference is originated, and thus it is termed as a EMF. And now we entered into our time for questions. How can we measure the potential difference or EMF? Generally, voltmeter or potentiometer or galvanometer or EMF cell or EMF meter is used to measure this potential difference which originated between the two different compartments of the galvanic cell. Generally, voltmeter is used to measure the potential difference or EMF across the electrical device that is said to be a battery. It must be connected in the parallel to electrical device in order to measure their potential difference across the ends of two electrical devices. Here, a parallel origination is the most important thing in order to measure its accurate potential difference from positive to negative end in within the battery. So here, voltmeter is the device to measure this. Now, when a battery in a torch is used for several weeks, the light from the bulb becomes dim. What could be the reason? When we are purchasing new battery, that will give a high luminous low. But after few weeks, its luminescence is slowly decreasing and the brightness now slowly transformed into a dullness. What could be the reason for this kind of change in its luminescence? Now we will see what you have a battery stored in energy in the form of chemical energy. Battery contains the chemicals which undergo chemical reaction spontaneously, and electricity is originated at the expense of chemical reaction which carried within the battery. And that used to run that torch, which used to illuminate that torch, chemical energy should be released. The battery stores a finite amount of chemicals which depletes the energy being used. When the chemicals becomes low in quantity, reactants will become negligible and electricity available also becomes negligible. This is the discharging process of battery. This how torch light will become dim and over time and it completely discharged. Further switching on, even illumination may not be possible because the complete reactants got converted into products. At that instance, there is no feasibility for operating that chemical reaction. As long as chemical reaction get carried, reactants to product conversion, at the same time energy liberation is also possible. If all the reactants got converted into product, there is no starting material to generate the electricity. At that instance, now the torch is becoming dull because there is no gain of energy by the expense of chemical reaction. So after some time, if you are still continuing the same process, entire starting materials got converted into products. At that instance, further lightening of this torch may not be possible because total reactants got discharged. So that could be the reason to explain this brightness and dullness which originated at different time intervals in the torch light. So battery is operating purely based on the chemicals which are embedded into the battery in a sequential manner so that they are used to give the energy. Now, any other question posed here? Is there any relation between the EMF of the battery and the drift speed of electrons in the conductor connected to the battery? So electromotive force, is there any impact on the drift speed of electrons in that battery? Yes, when EMF of the battery is more, the drift speed of electrons are obviously more, right? So there is a direct proportionality. As the electromotive force increases and the drift speed of the electrons also increases. I collected this answer from the platform called Doubtnet. Thank you very much for your valuable information. So here, as EMF increases, drift speed of electrons also increases, so that high efficiency is discharged by that particular battery. By this, we completed electromotive force. Thank you very much for your patience listening. Hope this session will helpful for your preparation. Thank you, one and all.